All right, this is our plan. So Monday, lesson. Tuesday, lesson. There'll be plenty of time in class to work on the homework. Okay? And then Wednesday, I'm going to hand everyone back their last quiz. If you didn't have it done, you don't get this opportunity. Okay, that's what I'm telling you. Get it done before class Wednesday, including if you need to come into advisory, all right? Thursday, I'm going to do the review. Actually, I'll probably get the review on Wednesday so you could work on it. Thursday, work more on the review. Friday, chapter test. And then we go into our review week. Okay, review week, I will have packets for each day. There will be a video that goes along with it. Okay, but Stone and I know those of you who just go to the video and just copy it down and say, oh, look what I got. It becomes obvious when I grade your test and you get a 5 out of 90. It's like, you didn't know what you're doing. So figure it out. I mean, we're coming down to the end.
Also, another really good technique, too, I haven't really taught you guys this. Another really good technique of understanding the content before taking a test is teach someone it. Teach a mom, teach a parent, teach a sibling, teach a friend. I know it doesn't seem, I know it sounds stupid, but seriously, when you know how to teach it, you know you understand it. If you don't know how to teach it or to tell someone what it is, then that's your first indication that you don't understand what the content is, if that makes sense, right? So think about that. Like, if you're really struggling, think about, okay, what are some studying topics I could try for this next test? Let me try it out and see how it goes before we have that fun. Okay?
Okay, friends, I'm on page 195. And it says, what do exponential functions look like? And what are some of the characteristics of the graph of the exponential function? Okay. So we're not going real deep in detail, but an exponential function, I will tell you, you have an exponent. You have something that is raised to, which is not a number. It's a variable, a letter. Okay. And the graphs, we're going with real basic graphs, where growth and decay. And you just have to kind of look at it. So, so we have that. All right. This is what an exponential function looks like. A and B will be numbers. And then X is the exponent. That's the first thing to realize. Okay, so let's see if we can figure this out. What's a to the 0? 1. What's b to the 0?
1.
What's c to the 0?
1.
What's d to the 0?
1.
What's 5 to the 0?
5.
1. What's 7 to the 0?
1.
What's 200 to the 0?
1.
What's 500 to the 0? Okay, you catching my drift? Okay, so that means when we're going to do these, we're going to be dealing with plugging a 0 in for the exponent, because things happen nicely when that takes place. You don't have this one. All right, so you start at A on the y-intercept, okay? If you go 0, comma, so this is an x value, you're looking for a y. If you plug 0 in, this will find where it crosses the y-intercept. Okay, that counts as a point. And then we're really going to make it simple, because we're either going to plug 1 in, or 2 in, or -1 in, or -2 in. That's all we have to do in order to get the exponential function. Okay, to graph it. It's pretty simple. Okay, so if you have something like this, this forms a straight line. If you have something like this forms a parabola. Straight lines are just x, or x to the first. Parabola is like x to the second. Now we're going to get like a number raised to an exponent. So this graph is going to look a little bit different. Okay? So there's going to be something called an asymptote. And for the first for just our 2 days, it's pretty simple to find the asymptote, but we're going to get to it real quick. All right. So these are what they look like. Both of these are growth. And a growth means as I go right, the graph grows away from the asymptote. Okay, so right now, this line right here is the asymptote. It's also the x-axis in this case. Okay, so as I go to the right, as I go that way on that board, or that way on that board, as it grows away, as I go to the right, as it grows away from the asymptote, that means it's growth. This one's called decay. As I go right, it gets close to asymptote. Okay? And again, the asymptote right now is this line right here. Okay? Now, things that are growth. If you start saving money for retirement, it will grow exponentially. If you had, let's say you had an ear infection and you went to the doctor and they gave you some medication, the medication is knocking off the bacteria that's causing your ear infection exponentially. That's why usually after a day or two of you taking some sort of antibiotic, you're starting to feel better. Okay? Do you guys know that you'll never kill off all the bacteria on that infection? It's impossible. But your body starts realizing, hey, this isn't our friend. There's only a couple of them. We got this. So it's kind of cool. Medicine works.
That's why cancer patients have such a hard time fighting off colds. Because chemo kills all those natural.
Okay. So the first thing I want to do, I want to figure out the asymptote. Okay? And how we find the asymptote, is, did we add or subtract anything? Okay? If I have 4 times 2 raised to the x, did I add or anything, or did I subtract anything? The answer on this one is this problem could be rewritten to look like this. If I add 0 to anything, it just stays the same. So that means my asymptote is right here. That's my asymptote. I cannot cross my asymptote. I get really close to it, but I can't get there. Okay, so that's the first thing I want to do. So first thing, draw this in. Okay, which we did. Now I'm going to pick 2 points. I'm going to go 0, comma, blank, and I'm going to go 1, comma, blank. And this is enough information for us to get the entire graph. So let's take 0, comma, blank. I'm going to take this equation, so I'm going to go 4 times 2 raised to the 0. What is 2 to the 0? 1. What is 4 times 1?
4.
So 0, comma, 4 is our first point. 2, 3, 4. It's right there. Is that good so far?
Yeah.
All right, now we'll do the other one in purple. I'm going to plug 1 into my original equation. So I'm going to get 4 times 2 to the first. What is 2 to the first power? 2. What's 4 times 2? 8. So I'm going to get 1 comma 8. 1, 2, 3, 4, 5, 6, 7, 8. So as I go to the right, is it going towards the asymptote as I go to the right? Or is it going away from it?
Away.
So is it growth or decay? Growth. Okay? So as I go to the right, away, it is going away from the asymptote that we have up there. Now, domain is pretty simple. Ready? Domain. Just like the parabolas, negative to positive infinity every time. The range is going to be a little bit different. What does it appear our lowest y value would be based on our graph? Where's that arrow coming to as I go to the left? In the y direction. Y is this way. What am I getting close to? What am I getting close to? That's not the y-axis. X-axis. The x-axis is what in the y direction? The x-axis, if I plot anything along this green line, I have a number, comma, 0. So over here it's like negative 10, 0, negative 6, 0, 0, 0. So I'm getting close to 0. This is coming close to 0. So remember, the range is like an elevator. So I'm getting close to 0. I'm real close to 0. I'm like on the very bottom of an elevator. So I start at the 0 and I go up forever. And that is our domain and range. Domain is always going to be negative, positive, infinity. Don't miss something like that. And our range is where it's our lowest y value and then goes up. Or in our lowest y value could be like negative infinity as well, but we'll see one of those in a sec. Questions about how I graph that? Can I move on? All right. So, can I have each of these be plus 0 and plus 0? Is that okay? So my asymptote's where? It's right along the x-axis, okay? So that's my asymptote. It's at y equals 0, okay? So if I added something to it, then my asymptote's going to either shift up or down. All right, so let's do this one in red. So I'm going to plug in my first point, 0 comma something. So I'm going to get 2 raised to the 0. 2 to the 0 is? 2 to the 0 is? 1. Okay. And then I'm going to plug 1 in. So 2 to the first power is? 2. So write 1 up 2. Friends, is this growth or is it decay? Is it as I go right, going away from the asymptote or coming towards it? This is growth. Because as I'm going right, it's going away. Okay? Now let's try the other one. We'll do in blue. Okay, so I got 0 comma something. So I'm going to go 1/2 times 2 raised to the 0. 2 to the 0 power is what? 1. So 1/2 times 1 is 1/2. So 0 comma 1/2. So it's like way little. It's right under here. All right, now I'm going to plug 1 in. So I'm going to go 1/2 times 2 raised to the first. What's 2 to the first? What's 2 to the first? 2. What's half of 2? 1. So 1 comma 1. So this one falls down here, and then grows. Is that growth or decay? It's growth. As I'm going away, as I go to the right, it's going away from the asymptote. So they're both growth models, regardless if I have the half in there or not. The half just means that it's not going to grow quite as quickly, but it's still exponential growth. So when we are dealing with these, we take a look. Am I adding or subtracting anything to the exponential thing? If the answer is no, then y equals 0 is going to be my asymptote. Then you're going to plug 0 in to the original to get 1 point, and then you're going to plug 1 in, and it doesn't always have to be 1, but most part 0 is for the most part going to work, unless we start doing right-left shifts, but I don't think we have any right-left shifts that we're going to do. All right, ready? Talk to me, friends. What's my asymptote? Am I adding anything to it? There's not a plus or a minus after this. So it's a plus 0 and a plus 0. Okay? This is my asymptote. Okay, am I adding or subtracting anything to it? Okay, that's where our question is. That negative is going to mean something here in a sec, but we're going to get to that. All right, so let's do this one in red.
And I would suggest, if you haven't kind of figured that out, I would bring in some other colors. If you have like color pencils or anything like that, or highlighter.
So 4, 1/2 raised to 0. What's half to the 0? 1. What's 4 times 1?
4.
So 0, 4. Right there. Okay. I bet you I can plug 1 in as well. So 4 times 1/2. 1/2 raised to the first. What's 1/2 to the first? 1/2. What's half of 4? 2. So I get 1 comma 2. So this one kind of looks like this. Friends, is this growth or decay?
Decay.
It's decay. The reason it's decay, as I go to the right, as I go this way, it approaches the asymptote. Okay? Let's take a look at this one. Let's plug 0 in. So I'm going to get negative half raised to the 0 power. What's half to the 0? What's half to the 0? 1. What's negative 1 times, or negative times 1? Okay. Let's plug 1 in. What's 1/2 to the first? 1/2. What's negative times half? Negative half. So 1/2 is here. So this is going to look like this. Friends, is this growth or decay? It's also decay. It's decay because as I go to the right, it's squeezing really close to the asymptote. Okay? So there's growth and there's decay. Okay? Now, I'm going to go back one slide. What is the domain for the blue and the red? What's the domain for each and every one of these? Negative infinity to infinity. Okay. What is my range for both of these? It's the exact same. What am I coming real close from? What's my lowest I'm going to be? At 0. It's going to go to infinity because it's growing upward. Okay?
I figured as much.
Me too.
Oh, let's put it in the pocket. You can put it in the pocket or I put. Which number do you want?
Annie. All right. Yeah. Was there a question? All right, friends, for this last one, the domain for both of these will be what? The domain for both of these is what? Negative to positive infinity. All right. So I'm going to do the range on the red first. What's my lowest y value I'm going to have? What's my lowest y value I'm going to have? It's my lowest y value on the red. 0. So it's going from 0 to infinity. But let's take a look at the blue. Where does this arrow pointing to? Negative infinity. So my range on this one's going to go from negative infinity to 0. Notice how it flip-flopped. Okay, you're talking about a vertical component with the range. Okay? So, my friends, I want to give you the opportunity to start working on these.
Can you clarify something real quick?
Yeah?
Because even the range is not making sense for me. So yes, it's the y, but how do you determine if it starts with the y or it determines the, like, how can, like, for some reason I can't, you see what I mean? Like, that's
Okay.
where I'm like.
So I'm going to be in an elevator, right?
Yep.
This elevator can only go up and down, correct?
Mhm.
On the blue, that elevator is going to be all the way down at negative infinity. And as I take the elevator up, it gets to the very tippy top level, which is the green line,
Okay.
which is 0. If I was in the elevator up here, on the red, the lowest I'm at is at 0, and it's going to go forever up, because again, the elevator is going to go up or down.
Okay.
Is that okay?
Yeah, that helps. Just because, like, for some reason, when I keep looking at the graph, I keep doing it backwards.
Okay.
That helps.
So, don't have to worry about that. Don't have to worry about that. All right. So find the asymptote first and graph it. Okay. For this assignment, our asymptote is going to be the x-axis every time. Okay. And then plug in 0, comma blank. Plot it. Plug in 1, comma blank, and plot it. Okay, and your graph is either going to look like this, could look like this, could look like this, or it could look like this. Okay? Yeah. Everyone's going different ways, huh? All right. So I want to give you the opportunity, and I'm happy to help you. But what's hard when you come up and help, and you get help, and I'm like, say 3 to the 0, and you're like, oh, I forgot. Like a number to the 0 power is gonna be 1. Got it? A letter to the 0 power is gonna be 1. So don't be like, oh, I forgot. Okay, that's an easy one. 197, 198. We can do 1 through 3, 8 through 12. Okay, there's not a lot of questions to do. Get it done before you walk out of here. Get your questions answered. Okay? Right there.